In this problem, we want to solve the equation, the square root of the quantity 2x minus 3 minus the square root of the quantity x minus 2 equals 1. So in order to do this, whenever I have two radicals in an equation, I will solve for one of the radicals. So in order to do that, I will add the square root of x minus 2 to both sides of the equation. And now I have the square root of 2x minus 3 equals 1 plus the square root of x minus 2. So now I can square both sides because I have a radical isolated. But when I do that, first of all, on the right-hand side, I have to use parentheses, and we're going to have to FOIL that. So I have the square root on the left of 2x minus 3, and we're squaring that. The radical and the square cancel out, and I just have 2x minus 3. On the right-hand side, off to the side, I'm going to multiply 1 plus the square root of x minus 2 times itself. And when I FOIL, I get 1 plus, so 1 for the first. Outer would be 1 times the square root of x minus 2. That gives me the square root of x minus 2. The inner is the square root of x minus 2 times 1. So I have another square root of x minus 2. And then plus, for the last, we have the square root of x minus 2 times the square root of x minus 2. So that just gives me an x minus 2, because the square root of something times itself gives you just the quantity under the radical. So now let's combine like terms here. Let's see, we have an x. 1 minus 2 gives me a minus 1. And then we have plus 2 times the square root of x minus 2, because I can combine, let's see, let me do this better. I can combine these two like terms together. Okay. So now this is the right-hand side, x minus 1 plus 2 square roots of x minus 2. Now I need to solve for my other radical. So I'm going to get the other terms over to the left-hand side. And to do that, I'll minus x from both sides, and I'll add 1 to both sides. So now I have 2x minus x, which is x. Negative 3 plus 1 is a minus 2, equals. The x and the minus x cancel, the negative 1 and the plus 1 cancel. So I'm left here with 2 times the square root of x minus 2. Now, at this point, I would get rid of the 2 in front of the radical if it was convenient to do so. But if I tried to divide both sides by 2, then I'll get a fraction on the left-hand side, and I don't want to deal with fractions. So since that's the case, I'm just going to go ahead and square both sides again now. Whenever you have two radicals in a problem, then you're going to have to square both sides twice. So we have x minus 2 quantity squared on the left, and 2 times the square root of x minus 2 on the right. When I square x minus 2, I get x squared minus 4x plus 4. Remember, again, I'm doing FOIL. So I just went ahead and did it this time since it's not as complicated as the FOIL we just did over in this area. Equals. Now I have to take the 2 and square it. That gives me 4. Then I take the radical and square it. Well, the square and the radical will just cancel out. So I have 4 times x minus 2. Okay, so next thing I'm going to do, let's see, I'm going to have to turn the page to make more room. All right. So we have x squared minus 4x plus 4 equals 4 times the quantity x minus 2. So I can go ahead and distribute the 4 on the right-hand side. And I have x squared minus 4x plus 4 equals 4x minus 8. This is a quadratic equation because our highest degree term is x squared. So since that's the case, I want to get all the terms together. I'll get them together on the left-hand side. That'll be the easiest way. So to do that, I minus 4x from both sides, and I add 8. Now I have x squared minus 8x plus 12 equals 0. Okay, so x squared minus 8x plus 12, that's pretty easily factorable. And I factor the x's. I have x and x. And 12, we need two numbers that multiply to make 12, and they need to add to make a negative 8. So we can use 2 and 6, and they'll both be negative. So now we'll solve our individual equations. We have x minus 2 equals 0, or x minus 6 equals 0. And that means that x equals 2, or x equals 6. So now I need to check my answers and make sure that they work. So if I plug in 2 to the original equation, then I have, let's see, square root of 2 times 2, oops, that should be a minus 3, minus square root of 2 minus 2 equals 1. 2 times 2 is 4, minus 3 gives me 1. So I have square root of 1 minus the square root of 0 equals 1, and that checks because that's just 1 minus 0 equals 1. So x equals 2 is a good solution. Now let's try x equals 6. 2 times 6 minus 3 minus 6 minus 2, and the 6 minus 2 is under the radical, equals 1. All right. So 2 times 6 is 12, minus 3 gives me 9. So I have square root of 9 minus 6 minus 2 is 4, so then we have square root of 4 equals 1. 9 square root is 3, square root of 4 is 2, 3 minus 2 does equal 1, that checks. So this problem has two solutions, and you can write your solution set like this. Or you can just give x equals 2 or x equals 6. And that is the final answer.